restart the recording because I must have stopped it. And let's talk about Kruskal-Wallis, and then if I have time, I'll be happy to work some other examples for you. Kruskal-Wallis has a little bit more work on the front end. Okay. So Kruskal-Wallis, sometimes also called the H test, is comparable to a one-way ANOVA. But like many of the non-parametric tests, it is less powerful because it does not require us to assume that the populations are normally distributed, nor does it require that we assume the population variances are equal. So because we kind of remove those two assumptions, okay, the test is not as powerful. I prefer to do a one-way ANOVA if at all possible. But if it's not possible, then I'm going to do Kruskal-Wallis. And the idea behind Kruskal-Wallis is it uses kind of a ranking system. It takes the data and puts them in order, say from low to high, and then numbers them 1, 2, 3, 4, 5, or how many ever there are. So it uses a ranking system, and then those ranks are used to calculate the test statistic. The H test statistic, which is used for Kruskal-Wallis, is approximated using a chi-square distribution. I'm not sure if we talked about chi-square before, and I'm not sure if I have it on the next slide or not. So if I don't, I'll come back to it. So hang on for just a second because I can't remember what's next. The one thing about using the H-test statistic is you need to have at least 5 observations within each group. And so sometimes that gets tricky if you don't have 5. Okay, I do have the chi-square distribution here. The chi-square distribution is much like the F distribution. It is not symmetric. It is skewed to the right as well, meaning you're going to have lots of values on the low end. Guys, am I sharing my screen? Are y'all just letting me?
I was getting ready to tell you, but I actually have walked away. I was like,
Oh,
I was going
I'm sorry. I'm sorry, guys. I'll back up for you. Okay. In case you were trying to make some notes. Okay, so Kruskal-Wallis, again, is comparable to the ANOVA. The two big things that are different is we don't have to assume that it's normally distributed, and we don't have to assume that our population variances are equal. But again, it uses kind of a ranking system. It puts the data in each group in order from low to high and ranks them. And then it uses those ranks to calculate the test statistic, which is the H. The H test statistic is based on or is approximated using what's called the chi-square distribution. The chi-square distribution is very similar to the F distribution. It is not symmetric. It is skewed to the right, meaning you're going to have lots of data on the low end and very few values on the high end. And as I mentioned to you earlier, with the skewed right distribution, the mean is just to the right of the peak. And again, because it is skewed right as opposed to being symmetric, the values are either going to be 0 or they're going to be positive. They will never, for an H test statistic, they will never be negative. The chi-square distribution, the shape, although it'll always be skewed right, is different for each degree of freedom. And the degree of freedom is determined by the number of groups that you have. And if the number of groups approaches about 90, okay, when the number of groups get to about 90, then the chi-square distribution can be approximated using the normal. Okay, so there are still some assumptions that we have to make with Kruskal-Wallis. Your dependent variable should be measured at the ordinal or continuous level. So for Kruskal-Wallis, your dependent variable could be words or categories, again, that are ranked. Okay, so you could use words or categories, but they could also be numbers that are at the interval or ratio level. Your independent variable has to be 3 or more categorical independent groups. Okay, so again, you still have that idea of the response and the factor. In this case, if it'll let me write it, let me see if it. Okay, the dependent variable is going to be like your response in the ANOVA. Okay, and the independent is going to be like your factor. And again, the key thing here is you got to have 3 or more groups. Again, you have to assume that your observations are independent, which is basically the same assumption we had before. There's no relationship between the observations. You know, there's no overlap in the groups, which is the same assumption we had for ANOVA. The distribution of scores for each group have the same shape, which means we also are assuming they have the same variability. Remember, because we're no longer going to assume that we have a normal distribution, and we're no longer going to assume we have equal variances. But we are going to kind of assume that the distributions are the same for each group. It just might be that they're all uniform, or they're all exponential, or they're all binomial. They're not necessarily normal. Again, I mentioned this earlier, but for our purposes, if the distributions are not normal, we're going to use Kruskal-Wallis. So if the scenario tells us that our distributions are not normal, then we use Kruskal-Wallis. And again, that's in the purposes of this course, to kind of help you make the distinction. Remember, with a non-parametric test, instead of comparing the means, we are comparing the medians. Okay, we're going to look at the medians of each group instead of the means. And again, our null is going to imply equal. So you're going to have something like there is no difference in the median amount of the variable, and your alternative will imply not equal. So it's the same idea as we had with ANOVA, okay, but we're looking at the median instead of the means, because it's the non-parametric test. Okay, it's a little bit more of a process because we've got to think about it. Okay, so really, in both cases, for ANOVA or Kruskal-Wallis, you've got to decide if your distributions are normal or not, or be told that they're normal. If they're normal, we're going to use one-way ANOVA, which is the better of the two tests. But if the distributions are not normal, we're going to use Kruskal-Wallis. To decide whether or not they're normal, we got a couple of options. We can either look at the box plots, or we can look at the mean, the median, and the mode for each group. And then as far as conducting a Kruskal-Wallis, again, if it's not normal, we're going to run Kruskal-Wallis, but we still have to state the hypotheses, identify the players, calculate the test statistic and its p-value, make a decision, and write a conclusion. And again, we do not run 2Ks with Kruskal-Wallis. We don't mix the two. For creating either the box plots or the descriptive statistics, whichever way you want to do it, okay, the keystrokes for that are on slide 7. Okay, on slide 7 is the keystrokes for creating either the box plots or the descriptive statistics, so we can determine if our distributions are normal or not. I suppose we could run a normality test, but it's just as easy if you're looking at the groups, because otherwise you'd have to pre-sort. On slide 8, you have the keystrokes for Kruskal-Wallis. And then we have the examples. So I've got 30 minutes, so I want to go over and look at the example of Kruskal-Wallis, at least one. Okay, so here's our question. It says, a meteorologist wishes to see if there is a difference in the number of deaths in the United States due to severe weather. The data from the past 6 years are shown here. So you have the table. At a 0.05 level of significance, is there a difference in the number of deaths from the different weather conditions? Okay, so the first decision really that I should make, and let me move this up a little bit so I can get all my data on the same page. Really, the first decision that I have to make here is am I going to do one way ANOVA or Kruskal-Wallis? Making that decision depends upon whether the distributions are normal or not. Now, if you think about a normal distribution, we learned early on that for a normal distribution, the mean and the median and the mode are all approximately the same value. So that's the easiest thing to do. But before I can even make that decision and do anything, I've got to put my data into Minitab. Okay, so we have our categories. Okay, my categories are lightning, tornado, flash flood, and a blizzard. And then you have the number of deaths. Okay, so I'm going over to Minitab, and I'm going to get a new worksheet. And I'm going to enter my data. So I'm going to enter my data for lightning, and then tornado, and flash flood, and blizzard. And under each, I'm going to put the values that I was given. Again, it's a lot of data entry, so you want to be extra careful and make sure that you enter the data correctly. Okay, then I go and I do it again for tornado. Then we do flash flood. and then we do blizzard. Okay, so I basically have taken the table that we were given in the problem and entered it into Minitab. And my first decision has to be, do I have normal distributions or not? Again, I want to look at it in terms of my descriptive statistics. So I'm going to go to Stat, Basic Statistics, Display Descriptive. I'm going to choose all 4 variables. Minitab will do all 4 variables for me at one time. I want to make sure it's going to calculate the mean, I need the median, and I need the mode. Now I can have it do other things, but I don't need the other things. Okay, so I'm going to click OK, OK, and let's look. Okay, the mean for lightning was 60, the median was 67, and there was no mode. For tornado, it was 40, 39, and 39. For flash flood, it was 57, 50, and there was no mode. 45 and 45 and no mode. So see, if I'm looking at this, remember if the mean and the median are basically the same value, it's normal. So the tornado could be normal, the blizzard could be normal, but lightning and flash flood are definitely not normal. If you prefer to look at the graph, let's look at the graph. We're going to do a box plot, and we want it to do categorical variables. No, that's not the one I need, sorry. I can't remember. Let me go back over to the slide because I can't remember how to do it. That's 2K's test. Okay, box plot, multiple Y's displayed separately. Okay, I didn't set it up correctly to do the graphs. Okay, so the best way is going to be to look at your mean and your median, but they're obviously not close to the same thing for at least 2 of the variables. Okay, so because it's not normal, they're all 4 not normal, I am going to do, okay, I'm going to make you some notes here. All 4 groups are not normally distributed because the mean is not approximately equal to the median. So we run a Kruskal-Wallis. But the process is virtually the same. I mean, you're still going to state your hypotheses. Okay, so the first step, oh, come on, don't do that, is to state the hypotheses. The null has to imply that it's equal. The alternative will imply it's not equal. And again, we use basically the same phrasing that we had before, except we're looking at the medians. So we would say there is no difference in the median number of deaths due to severe weather events. Again, the difference with this one is that we're doing median, not mean. And again, the phrase no difference implies they're equal. The alternative would be there is a difference in the median number of deaths due to severe weather events. Step 2, whoops, sorry, I hit the wrong button. Step 2 in the process is to identify the players. Hadn't changed. The players here are your data that's given in the table with the scenario, and you need your significance level. And with the significance level, you need to calculate or determine the confidence level. So in this problem, let's see what it says. At a 0.05 level of significance. Okay. So my alpha is 0.05, which means my confidence level is 95%. Third step is to calculate the test statistic, which is going to be the H, and its p-value. Now, Minitab's going to do most of the work here for you behind the scenes. Okay. So I've already entered the data. I had to enter the data to compare the mean and the median. So I've already entered the data. We go to stat, non-parametrics, Kruskal-Wallis. My response is, oh man, I've entered this data wrong. Okay, guys, Miss Ralston has screwed it up. Because in order to do Kruskal-Wallis, we're going to have to do a different way to enter it. Okay, so we have to put the weather in one column because the weather is our factor and our response is the number of deaths. Okay, I apologize. I forgot this part. I don't do Kruskal-Wallis very often. Okay, so the first 6 have lightning. Okay, so I type in lightning and then I enter the number of deaths for each one. So it's almost like a coding system. You put the weather and then the corresponding number of deaths. And then the next column, I have tornado, and I have 6 values. And I enter the values for tornado. We're putting everything basically in 2 columns. We're combining, instead of 4 columns, we're going to have 2 columns. You have to repeat, okay, you have to label every numeric value. So I have to indicate what weather event it was. Now I'm putting them in order based on the table. I'm going to put flash flood. Again, there are 6 values. Okay, so I entered it 6 times. Then then you put the corresponding deaths. And I'm looking at my paper. And then the last one is blizzard. Okay, so you're taking the table and basically you're stacking it on top of itself. Okay, one row on top of the next row. Okay, so that you end up with one row that has all of the events or the words in it, and you have a row or column, excuse me, that has all of the data. I apologize. I forgot that part. Miss Ralston's entitled to one little small mistake, maybe. Okay. So instead of having it in 4 different columns, I now have it so that all of the events are in a column and the corresponding number of deaths are in the other column. Remember, the words are your factor, the numbers are your response. So let's try it again. Stat, non-parametrics, Kruskal-Wallis. My response is the number of deaths. The factor is the weather. And I'm going to click OK. And Minitab calculates my values. Okay, it gives me the descriptive statistics, which I don't need, and it gives me my test statistics. Okay, so I'm going to copy those over here to my paper, wrong paper. Okay, once Miss Ralston got it entered, okay, and let me make you a couple of notes here. Okay, really from the beginning, we should enter all the categories in a single column. Okay, you do have to do the repeats. If it occurs 10 times, you got to type it 10 times. Okay, and then you enter the number in the next column so that you have the categories, remember, are what we call the factor, The numbers are your response. Okay, we are going to use the one that is not adjusted for ties. Okay, we're going to use the one not adjusted for ties. So my H test statistic is 5.61 and my p-value is 0.230. Then we go to the fourth step, which is the same as we always do. We make a decision by comparing the p-value and alpha. So for this problem, my p-value, which we get from Minitab, is 0.230. Alpha is 0.05. Again, we compare that digit for digit. 2 compared to 0. 2 is greater than 0, so p is greater than alpha. If p is greater than alpha, we fail to reject the null. If I fail to reject the null, okay, and I move on to step 5, step 5 is we write our conclusion. Again, you always include your significance level. So we would say at the 0.05 level of significance, there is no difference in the median number of deaths in the United States due to severe weather. Guys, the process has not changed. The biggest difference here with Kruskal-Wallis is one, you're comparing the median because we are not assuming the distributions are normal. The other issue, and again, it's one that I missed, okay, is the way that you have to enter the data. For Kruskal-Wallis, you have to enter the categories Oh, come on. You have to enter the categories into one column and the numeric values into another column. Okay. So I don't have time to do it, but if I were going to look at the next example, which looks at precincts in Atlanta, they have precinct 1, 2, 3, 4, 5. So when I go to enter that into Minitab, I'm going to put the precinct number, which is going to be my factor, and you may want to label it as your factor. So I could have 1, and for each precinct, I have 5 values. So I'm going to have to enter 1 5 times. And then I have to enter 2 5 times because I have 5 values for precinct 2. And then I have to enter 3 5 times and 4 5 times because I have 5 values for each precinct. Okay, so I have to number and you have to do the repeats. Then in the next column next to it, you're going to put, in this case, we're talking about the number of crimes per week. And that's my response because that's the numeric value. Again, you got to make sure you keep them paired up. So all the ones, it doesn't like that. Okay, crimes per week. And that's my response. Okay, and you got to keep them. So for precinct 1, I'm going to put the values that I was given for 105, 108, 99, 97, 92. And then I go to precinct 2 and I'm entering 87, 86, 91. Whoops, not 19, 91, 93, 82, and so forth. So that when you're finished with Kruskal-Wallis, it's a special way to enter it, different from the others. You have to put all of the factors in one column and the corresponding responses in a second column so that you only have 2 columns of data. And I do apologize that I forgot that piece. But I think you can handle it. All right, ladies, I got 5 minutes left. Do you have questions?
I always have a question.
Okay, go ahead.
For the responses, you said put the numbers. So I just put like 105, 108, 99, 97, 92. Is that what
Yes,
I was
yes,
trying to
ma'am.
copy it?
Yes, ma'am.
Okay.
Hold on. I'll go back to it for you. Okay, those numbers are given to you in the table with the problem. Okay, but in the table, see how they're like side by side in like individual columns?
Yes.
I'm taking those columns and I'm stacking them. So I'm going to type 105, 108, 99, 97, 92. And then I'm going to go and do precinct 2. But it's sort of, think about it almost like color coding. Okay, so I've coded the first 5 responses as precinct 1 because they were for precinct 1. I've coded the next 5 for precinct 2 because they're for precinct 2. And then when I get to precinct 3, I've got them coded for precinct 3, and I would enter 74, 83, 78, 74, and 60. And then I'm going to precinct 4. So it's sort of like color coding or matching them up, but you're putting them all in a single column. You have one column for your precinct number or your factor, and you have one column for your response.
Okay.
And you only have to do that for Kruskal-Wallis. Okay.
Okay, that's all I had. I got it. Thank you.
You're welcome. Kaylee, you have anything, honey?
No, ma'am. Thank you very much.
Okay, ladies, remember that next week is spring break. We do not have class. Mini Project 5 is due by Sunday. The homework on ANOVA and Kruskal-Wallis is not due until the 12th of April. We do not have class next week because of spring break. So I will not see you again until April the 13th.
I'll miss you.
All right. You guys have a good spring break.
You too. Take care.
You too, Mr. Austin.